So here in this question, what you have to do, you have to find out some rational numbers between given two irrational numbers. Okay, so here it is root 2 and root 3. So between these two numbers, you have to find some rational number. So how did we do it? We said that we know that if we have numbers written like root 2, root 3, root 4, root 5, so whatever numbers are there inside the root, if you write them in increasing order, then the overall value of that is also in increasing order. It means what I'm trying to say is root 2 is smaller than root 3, which is smaller than root 4, and so on. So this is the ascending order of numbers. Same way, if I want to write a number which is slightly bigger than root 2, I can write a number like root 2 and then add some decimal part to it. Root 2.5 is greater than root 2. Okay. If I want to write a number which is just smaller than root 3, so I can write 2.8 and then put a bracket on root on it. So 2.8 is smaller than root 3. So this is how I know that these two numbers are lying between the two. Okay, root. Now I should not choose randomly any number. Okay, what number should I choose? Something which is a perfect square. Okay, this is one of the methods of solving the problem, choosing a perfect square number which is between 2 and 3. So as you can see, 2.25, 225 is a perfect square number, right? 15 square gives you 225. So same, I took this 225, but I want a number which is lying between 2 and 3. So I wrote it as 2.25. Why exactly two places of decimal? Because I can remove the decimal and then write it as 225 by 100, like you can see here. 2.25 can be written as 225 by 100. So you see now the numerator is also a perfect square, denominator is also a perfect square. So both of them will come out of the square root and you can write it as 15 by 10. So this number, when you cancel it, 5 3s are 5 2s are, so this becomes 3 by 2. This 3 by 2 lies between root 2 and root 3. This lies between root 2 and root 3, and it is a rational number because we have written in the form of p by q. So this is the best method which I think you should use to find out numbers between irrational numbers like this. A lot of people have done like, you know that root 2 is 1.4 or something and root 3 is 1.7. So you have written numbers like 1.5 which lies between that. So that you can do when you know the root 2 value and root 3 value. What if I ask you to find number between root 6 and root 7? Do you know the value of root 6 and root 7? What if I ask you to do between root 13 and root 17? So it will not be easy for you to write the decimal parts of all these things, no? So it's better to find some perfect square number which is between those two and then do the square root of all that to get a fraction like this. Everyone understands this? Tell me.
Yes, sir.
Hari, this was your question. Is it clear?
Yes, sir. Sir, 8 questions.
Sir,
Yes, Ritesh?
sir, I wrote the same answer, sir.
This
But
one?
I didn't write 3 by 2, sir.
Yeah, but you wrote 15 by 10, right?
Yes, sir.
Yeah, so you should cancel and write it as 3 by 2, but still I have given you marks, I think, for this one. So even if you write 15 by 10, I gave you marks, I did not deduct it, but whenever you have a number like that, which can simplify, it's always a better idea to simplify and write like this.
No, sir, but you give half marks, sir.
Half marks?
Yes, sir.
Okay, I will check. That would not be because of this. I think you would have made some other mistake. I will check it out. Okay.
Okay, sir.
And one more thing I want to remind all of you. See, question numbers are very, very important in the board exam. Does not matter what you have written. If you have not written your question numbers clearly, the people in the board exam, the people who are correcting your paper, they will not even look at your answer. Don't even think that they will give you marks. Doesn't matter if it is 1 marks or 5 marks. If you don't write the question number, you will get 0 marks for that question. So be very, very careful. And from going whatever tests we have from now on, if I see that anyone has not written the question or the question number is not written very clearly, neatly, I will not give you marks for that question, so that you have a proper practice before your board exam. You need to be very careful from now on, okay? Write your question numbers. At least 2-3 people did not write question numbers properly. Yeah, Charan, you were asking fourth question.
Yes, sir. The question is saying which is the smallest number which divides, but you have in solution we are doing LC, we are finding LCM.
Yes, see what is, write the smallest number divisible by, yes,
Sir, I also having confusion, sir. This, sir.
yes, let's
I
talk.
done HCF, but you.
Yes, let's talk about it. See, so when you have to find the smallest number which is divisible by these numbers, they're not asking find the smallest number which divides them. Okay, if you find the HCF, you get the HCF as 9 or something, right?
Yes, sir.
Okay, so 9 is the smallest number or the biggest number which divides both of them. That's what the HCF, right? Highest common factor. This is the highest, the biggest number which divides this and this exactly. Okay, they're not asking for that, the biggest number which divides both of them. They're asking the smallest number which is divisible by both of them. So if you find 9, is 9 divisible by 306? Divisible by means what? 306 should divide 9. Do you understand the difference?
Yes, sir.
Divisible by.
Understood.
Okay. Everyone, is it clear? Some other people have also made mistake in this, LCM and SCF. Is it clear?
Yes, sir.
Yes, sir.
They're asking divisible by. So if that number should be divisible by 306. So of course, this is divisible. This number 22,338, it is divisible by 306 also, and it is divisible by 657 also. And this is the smallest because it is the LCM, least common multiple. If you multiply 2 to it, that will also be divisible by both of them, but still it will be not the smallest one. Anyway, so this has to be LCM, smallest number. Whenever they say smallest, you should get a hint that it is LCM, but don't blindly look at that. Just see what they are asking. It should be divisible by means LCM. Okay, next one, 8th question. So somebody had a,
Yes, sir.
yeah, so you need to make sure that you use, when the question says Euclid's division algorithm, you have to use that. But it's okay, I gave you marks for this one because there is a possibility that Euclid's division algorithm may not be there for your syllabus. So,
Sir, I did it in a hurry, so I didn't look the question.
yes, so I am being lenient slowly a little bit because we have started just 2 months in the class, but as we go forward, the tests will be little stricter. I will not give marks for something which is not asked in the question. Okay, so reading the question is a very important part. And I have seen some of you have made some silly, really silly mistake because you did not read the question properly. So always remember, when you read the question, find out how many answers are needed. Are there 2 parts to this or 3 parts? So you have to answer all the 3 parts or 2 parts, whatever it is. And whatever they are asking, try to answer only that much, not more, not less. Okay, so this 8th question, show that every positive odd integer is of the form this or this. So it's the same thing which we have done Euclid's division lemma. Like if you want to show that some positive odd integer, take it as n, okay? Let n be that odd positive integer. Now, since we want to write it in the form of 4q plus 1 and 4q plus 3, you know that we have to divide it by 4. So if you remember your Euclid's division lemma, there are 2 numbers, a and b. And if a is divided by b, it can be written as, a can be written as b times of q plus r, correct? So here I have taken n is equal to, a is equal to your n. Basically, n is the odd number. And then we are dividing it by 4. It can be divided by any number, let's say. It can be divided by any other number also. I can divide it by 3 also, 6 also, anything. But since they have asked us to for this particular form, so this will come only when we are dividing it by 4. That is why I have taken my b to be 4. That's why I'm dividing it by 4. So when you divide by 4, let's say that Q is the quotient and R is the remainder. Okay. Then by divisional lemma, what do we say? N can be written as 4 times of the quotient plus the remainder. And then remainder can be what? Remainder has to be greater than equal to 0 and less than the divisor, which is 4 here. That is why R will be 0, 1, 2, and 3. Everyone is clear up to this? Whoever had doubt in this?
Hi, sir.
Okay. So, yeah, so that is your R values. Now, if that is the case, then this N can be represented in 4 different ways, right? I've told you, if you divide any number by 4, there will be 4 ways to represent that. If you divide by 7, there will be 7 ways to represent the number. So since we have divided by 4, there are 4 ways. What are the 4 ways? When R is equal to 0, like this one. When R is equal to 1, here, R is equal to 2, and R is equal to 3. These are the 4 different ways in which any positive integer or odd integer can be represented, or any number can be represented N, okay, that can be represented. So now out of these 4 ways, we can very clearly see that the first one, 4q is a multiple of 2, no? 2 times of 2q. So this is an even number, right? This cannot be odd. 4q cannot be odd because 2 is a factor over here. Same way 4q plus 2 also, you can see I can take 2 common and write it as 2q plus 1. The 2 is a factor, right? This number also becomes even. Is it clear, Hari? 4q and
only 1 and 2.
okay, I'm not able to hear you, Charan. Say that again. Hold on, Charan. I'm not able to hear you. If you have some earphones or something, maybe take it off and try to say whatever you're saying.
So the question they are taking a part to the remainder itself you can only take 1 and 2 also.
No. See, they're asking you to show that every odd integer can be only of this form. So how can you say that they're only this form? How can we, if there are Euclid's division lemma tells you that all these 4 possibilities are there, so I can't just blindly take 1 and 3, no? I have to take all of them and then show that why these 2 can be rejected, 0 and 2. So that's what I have done. I have taken all the 4, but I have rejected these 2 because these 2 are even numbers. But the question says the number has to be odd. So you have to show that you are rejecting these 2. That is why these are the only 2 possible ways in which odd numbers can be represented. Understand that? Charan and Hari, do you understand? There are 4 ways to represent the number, and I'm telling you these 2 ways are even numbers. So what are the ways which gives you odd? This number and this number, this is odd. Odd numbers can only be represented in these 2 ways. That's what you have to explain them. Is it clear? Confirm all of you.
Yes, sir.
Hari?
Yes, sir.
Okay. So any other doubts?
Sir, the extra sum.
Extra sums, okay. Yeah. So what does it say? Show that the square of any positive integer cannot be of the form this. So they're asking it should not be of this form. And they're talking about the square of any positive integer. So whenever they talk like that, any positive integer, that is what you consider your A from the Euclid's division lemma. This number becomes your A. And what are we going to divide by it? What is our B here in this case? Because we want it in the form of 5q plus something, 5q plus 2 and 5q plus 3. So of course we are going to divide this number A, any positive number, by 5. Correct? So that's what I have taken. Instead of calling it as a, I have taken it as n. So n be any positive integer. And when you divide it by 5, then the quotient, let it be m, and the remainder be r. Why did I take m and r, not q and r? Because I will first write it in the form of m. As you can see, I will write all the different forms. 5m, 5m plus 1, plus 2, plus 3, whatever. Okay. So I think I wrote 2 times, right? 0, 1, 2. Yeah. So this I wrote twice. So you can ignore this one. Okay. So if we are dividing any number by 5, what did we learn? That it can be represented in 5 different ways for different values of r. R will be 0, 1, 2, 3, and 4, right? So these are the 5 ways. I wrote it in all those 5 ways, and then I did the squaring because they asked square of that positive number, right? Square of that number. So do the squaring of that number, n square. So if r is equal to 0, then n can be written as 5m. So 5m square can be written as this. 5 into 5, 25m square. So you can take the 5 common and write it as a 5 cube, where q will be some integer. We don't care. It could be some integer. That in this case will become 5m square. M is an integer, so 5m square also will be some integer, and that integer we are calling it as q. Okay. Everyone okay with this so far? Guys, are you people
I
there? Didn't understand?
No, sir.
Okay, which part? Didn't understand anything, or some part is troubling you?
Sir, after that n square, this one, sir, n square is equal to.
This one?
Ah.
Okay. Had you attended the Euclid's division lemma or that class?
I didn't do only, sir. I am in confusion only, sir. Like eight questions. No.
Okay. No. Were you there when we took this class, Euclid's division lemma, or you had joined late?
No, sir. I was having that time network issue, so I didn't listen properly.
Okay. So you can go through the recordings also. Okay. I'll try to explain this right now, but you can go through the classes when we discuss this Euclid's division lemma. So maybe I'll send you the lecture numbers. You can find it in the playlist. Go through that and you will understand why we are doing this. So this kind of problem where some positive number is given and you have to show that the square of that number will take some particular form, then this is the process you need to go through. Okay, you will take that positive integer as something and you will divide it by some number. You have to decide which number to divide it by. So based on what form they are asking. Here they are saying 5q plus 2, 5q plus 3. That is why we are doing a division by 5. Because only when you divide by some number by 5, that is when you get this kind of form, no? So we are taking m as the quotient. So 5m, 5m plus 1, 5m plus 2. These are the 5 ways to represent any given number. Okay. Now, once you know that these are the 5 ways of representing the numbers, we'll do the squaring of all of them. Square all of them one by one, because they wanted you to prove that square of that number, square of any positive number cannot be of this form. So if it cannot be of this form, what form can it be? Let's find out and show them, okay, it has to be some other form. That's why it cannot be this form. Do you understand the logic we are going to follow? We are going to show them what kind of form square of any positive number takes. And then once we have proved them that it can take some other form, then we will actually prove that it cannot take this 5q plus 2 or 5q plus 3 form. So once you have represented n as these 5 different ways, that's what we normally do. No, we take case 1, case 2. So I have combined all of them. Instead of writing 5 different cases like case 1, case 2, case 5, I've combined, I've written that in short. Basically, you can call this one as case 1. When n r is equal to 1 here, you can call it as case 2. This is your case 3. In this case, r is equal to 2. Here r was equal to 1. Here r is equal to 0. Then this one is your case 4. R is equal to 3 this time. And this is the final case, case 5, where r value is 4. So all these 4 different values of r we take, and we show that when we do the square, it takes some other form. So these calculations we have done so many times, right? So when you have the number as, like, let's start with the first case. When n is written as 5m, as you can see, n can be written as 5m. N square can be written as what? N square will be 5m ka whole square. So 5m whole square can be written as 25m square. No, normally this is what you will write. 5m square will become 25m square. But this is not what I want. I want it in the form of 5q plus something or 5q minus something, whatever. So take the 5 common outside and see what is remaining. So from this 25m square, I have taken the 5 out. So as you can see, 5m square is left out. Okay. So 5 into 5m square, this is the form it takes if r is equal to 0. And that 5m square, I can write it as some integer q. So this is the form it will take when r is equal to 0. What happens? What form will this n square take when r is equal to 1? For that, you do the n square and put r is equal to 1 in that case. So it will become 5m plus 1. Do the squaring, simplify it further like this. You know, a plus b whole square, we have done the identity here. A square plus 2ab plus b square. And again, from these two parts, I can take the 5 common. I have left out this 1 as it is because there is no 5 in that. So leave that plus 1. From these two, 5 is common. So I have written that 5 common here, and the remaining part, it will be 5m square, and this will become 2m. Okay. Hari, you are able to follow?
Yes, sir.
Okay. So this 5m square plus 2m, which is there inside this bracket, I have considered the whole thing. This is going to be some integer, right? M is an integer, so m square will be integer. Some integer into 5 will also give you integer. And these two are integer. When you add them, this will also be some integer. It will have some different value, but we'll call that value as q. So it will be 5q plus 1. This is the form it will take when r is equal to 1. So we have seen that when r is equal to 0, it takes the form of 5q. When r is equal to 1, it takes the form of 5q plus 1. When r is equal to 2, it takes the form of 5q plus 4. Still, it has not taken the 5q plus 2 form, which they are asking. See, 5q plus 2 form is not coming. 5q plus 3 form is also not coming. That is what we needed to prove, that it cannot be represented in this form. So right now we are showing that it can be represented as 5q, 5q plus 1, 5q plus 4, and then take the value of r is equal to 3. We say that again here also it becomes 5q plus 4 only. So there is no 5q plus 2 and 5q plus 3. I showed the last one, r is equal to 4. This form also takes 5q plus 1 only. So we have exhausted all the possible scenarios. No? Out of all the 5 cases, we showed them that it can only take either the form of 5q, 5q plus 1 or 5q plus 4. These are the only 3 possible ways in which n square can be written. So if these are the only possible ways, then this cannot be the way. That's what we have written. Square of positive number cannot be written in this form. So 1 of every 3 consecutive integers is divisible by 3. So we show that n can be represented in 3 ways, and out of these 3 ways, only one of them, this 3q, is divisible by 3, and rest of them is not divisible by 3. So we showed that out of the 3 ways, 3 numbers, these are consecutive numbers, no? 3q, 3q plus 1, and 3q plus 2. These are the 3 consecutive numbers. You can check it. Take the value of q as 0 and see what happens. 3q, 3q plus 1, and 3q plus 2, q is equal to 0. What will happen? 3q will become 0. 3q plus 1 will be 0 plus 1, that is 1. And this will be 0 plus 2. This will be 2, 0, 1, and 2. So by writing 3q plus 1 and 3q plus 2, if I take q is equal to 0, I am writing 3 consecutive numbers. And out of these, only one of them is divisible by 3. So in this case, I took 0, but they said that q is a positive integer, so we can't take 0 basically. We should have taken q is equal to 1. So let's take q is equal to 1 also. What will happen if I take q is equal to 1? It will be 3, 3 plus 1, 4, and 3 plus 2, 5, 3, 4, and 5. So out of these numbers, you see only this first one, which is 3q. That's the only one which is divisible by 3. Remaining will never be divisible. That's the logic we have followed here. This is how you will write it. So go through the solution, how to write it, and then. So there are some word problems in the first exercise which we have not talked about. So we'll talk about these questions. And also remember, what things I have taught you so far. I have taught you the graphical method of solving.
Elimination.
And then in the algebraic methods, I taught you elimination and substitution. The third method, cross multiplication, I have not taught you as of now. Okay. So if anyone knows how to solve this, you can do that in your home and try to practice. Okay. That's it, guys, for this class.
Sir,
Yes, Ritesh, tell me.
sir, should we find solutions for exercise 3.1, sir? Represent this situation algebraically.
Yes, right now they're only asking you to represent, but later they will ask you to come back and solve them also. So since that's why I taught you how to solve them using graphical method, elimination method, substitution method. Now we are coming back to this because now you already know how to solve the equations, right? So you can just go through the equations, form the equations, and then solve them also in one go itself, okay? So that we don't have to come back to this again. So you'll solve them also.